Hey everyone! Have you ever looked up at the sky and just wondered, why is it blue today, but a fiery red tomorrow at sunset? It's one of those simple questions we ask as kids. But the answer is actually a fascinating journey into physics and the science of our atmosphere. So, let's dive in and uncover the secrets behind the sky's amazing color palette. First, let's get one thing straight. The light from our sun isn't just one color. It looks white, but it's actually a mix of all the colors of the rainbow: red, orange, yellow, green, blue, and violet. Each of these colors travels in waves, but they're not all the same. Blue and violet light travel in short, choppy waves, while red and orange light travel in long, lazy waves. This difference is the key to everything. Now, imagine this light from the sun starting its long journey to Earth before it can reach our eyes. It has to pass through our atmosphere, which is a thick blanket of tiny gas molecules and other small particles. When sunlight hits these molecules, it gets scattered in all directions. Think of it like a pinball machine, where the light is the ball and the air molecules are the bumpers. Here's where it gets really cool. The short, choppy waves of blue light are much more likely to hit these molecules and scatter all over the place. This phenomenon is called Rayleigh scattering. Because blue light is scattered so effectively in every direction, it fills the sky, making it appear blue to us down here on the ground. You might be wondering, what about violet light? Its waves are even shorter, so shouldn't it scatter more? Well, it does. But our eyes are just more sensitive to blue light, and the sun emits less violet light to begin with. So blue wins out and paints our daytime sky. So, if the sky is blue during the day, what's happening during sunrise and sunset to create those spectacular reds and oranges? At these times, the sun is very low on the horizon. This means its light has to travel through a much thicker slice of the atmosphere to reach us. It's like taking the scenic route instead of the direct one. As the light travels this longer distance, it encounters way more air molecules. All that extra scattering takes its toll. The short wavelength blue and green light gets scattered away from our line of sight almost completely. But the long wavelength red, orange, and yellow light can push through this dense atmosphere much more easily. They're like the marathon runners of the light spectrum. So, by the time the sunlight finally reaches your eyes, all that's left are those warm, beautiful colors. This is why sunrises and sunsets are such a vibrant spectacle. The colors can get even more intense when there are more particles in the air, like dust, pollution, or water droplets from clouds. These larger particles also scatter light, particularly the longer wavelengths of red and orange, adding to the fiery display. That's why sunsets can look especially dramatic after a storm, or in areas with more atmospheric dust. And what about a cloudy day? When the sky is full of clouds, it just looks white or gray. That's because the water droplets in clouds are much larger than the air molecules. They're big enough to scatter all colors of light equally. When all the colors of the rainbow are scattered and mixed together, what do you get? White light. If the clouds are very thick, they absorb more light than they scatter, and that's when they start to look dark and gray, signaling that rain might be on the way. So, from the brilliant blue of a clear afternoon to the deep crimson of dusk, the color of the sky is a beautiful, ever-changing story told by light and air. It's a daily light show put on by nature, all thanks to the simple physics of light scattering through our atmosphere. Next time you look up, you'll know exactly why you're seeing what you're seeing. It's a little reminder of the incredible science that's happening all around us, all the time. Thanks for joining me on this colorful journey through atmospheric science. If you enjoyed this video and learned something new, don't forget to hit that like button and subscribe for more curious explorations. Let me know in the comments what your favorite sky color is. Until next time, keep looking up.